Now let us export our work to the PCB. And I said earlier that we can do that by hitting on tools, update PCB from schematic, right? And once we do that, we'll get this dialog box showing us if there are any errors in what we are doing. So in case there are any errors, let's say some pin mismatch and some pins are not connected and all that, we will see that, right? So once I hit update, then what will happen is that, so close, and what will happen is that it actually opens the PCB, the PCB editor, okay, and put all the components there as we specified. Okay, so let me move them to the center. Okay, so the components that we need for our PCB, that's what have been exported here. Is that okay? Now at this point we can take a look at the 3D view by going to view and bring up the 3D viewer. And as you can see, this is what we have at the moment. Is that okay? But then you can see that we are missing one component. Is actually missing what do you call it? A component is missing a 3D model, right? Now this is something that we can easily fix. Okay, now we can fix it permanently or fix it temporarily. Is that okay? For now, I'm going to fix it temporarily so that we can just go ahead and arrange our things, and then tomorrow I'll show you a permanent way of doing that. Okay, so the first thing you need to do is to get a 3D model. Now chances are that somebody has already designed this and you can just download it from online. So the first place I would like to search will be DigiKey. If I search for DC barrel 5 something like that, and I'm lucky, I would get one. Okay, so DC barrel power connectors, yes. And then we search through. Okay, so it looks like this is what we are looking for. Yes, 2 times 5.5. So once we select it, it will give us detailed information on that, and it will give us detailed information on the component. Okay, so let's check it out. So you can see if you scroll down here, it will even tell you how much current it can stand. Okay, so it's rated for 12 volts AC slash DC. It can handle 500 milliamps. Wow, so this thing is technically not a good one, but let's just use it for using sake. Tomorrow we will pay attention to this stuff. Okay, all right, so let's see, do we have EDA models? Yes, so let's check the EDA model out. Okay, it is still loading. All right, so unfortunately we don't have 3D model associated, right? So good, all is not lost. Now we can also go to a site called 3D Content Central. 3D Content Central. Okay, here it will require you to sign in. Okay, so I will do just that. I hope I remember my password. Oops. Oh, that's no good. Okay, let me try. Please, 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 please. And I think this works. Yes, so I remembered my password. So we are looking for DC barrel. Can type just DC barrel. And if we are fortunate, we will get a 3D model. So usually you get all this nonsense, and then you have to sometimes to depending on the parameter. So let's also check DC jack. I think it's about the name. Okay, let's look for barrel jack. I mean, this thing should be easy to get. Barrel jack. Unfortunately, we still don't have okay, let's say barrel, just barrel. Unfortunately, we don't. Okay, but at least let's go through the first. So this time we are getting something. Okay, what about the last search, barrel connector? So take note of this website that I'm putting around. Okay, so we don't have it. Well, there is still one place to search. Okay, the last place that I know definitely we will get will be grabcard.com. This is also another site that hosts 3D models for free. So once we come here, we go to libraries, and then we can search for what we want. So DC barrel, and voila, you can see that we have it here. Is that okay? So this is what we are looking for. So we click on it, and then we want it 3D. So I have to log in again. Yes, so far as you are assistant designer, these places you would have to create accounts. Okay, so you are looking for a 3D model of it. Okay, in case your search is becoming long, just scroll down here. You are looking for a step file. A step file. Okay, so this is barrel. Go through it, loading. This is not the step file. This is not what we want. Why is this PCB mounted? Let's check this folder. This is not a step file. Okay, all right, let's just go back. We want step files. We don't want oh, okay, so you can see 3D. Okay, and you can actually check it out in the on the site before you even download it. Okay, so you can see that this is DC barrel 2.1 mm step. That's exactly what we are looking for. Is that okay? So the next thing that we do is to download the file and save it to a place that we want. Now, usually, in case you'll be sharing this project with somebody, then I would advise you save it in the file, in the folder that you have your work. Is that okay? So I'm downloading because I use a downloader. The downloader is actually taking time to pop up. Okay, so let me hit that again. Let me see if I can fast forward the thing. So FDM. All right, so here we go. Yep, so this is the step file, and you can see DC blah blah blah. So I'm going to save this. I'll navigate and save it in the folder in which I'm working, and I'm working in a folder in my documents, KiCAD, hello world, right? Good. So let me create a folder here and call it 3D models. Okay, so in case I share this project with somebody, the person will not get the 3D models not connected. Is that okay? So open it, and I'm going to save it there. So I'll download it quickly. Remember, I clicked on it twice, so I can cancel the second one. So once the download is ready, I can open it, close my downloader, and also I need more memory. I'll close this. Okay, so this is how you attach it. Okay, so if you look into my folder right now, you can see I have my work files here, and I have my 3D model folder. Inside it, I have my 3D. Whoa, it didn't save in the 3D. Oh, okay, yeah. So I failed to select. So let me just move it to my 3D models folder. Right. So now, how do I attach it? So in the footprint editor, in the PCB editor, you can right click on the component, go to properties, okay, and when in the properties dialog, look for the 3D models. Okay, you can see that there is supposed to be some attached, but it is broken, right? So we can delete it and now attach what we downloaded, right? So we can do that by clicking on this folder to navigate to that 3D model. Okay, so we saved it on drive D, so it should be on users, Profesir, documents, document KiCAD, hello world, 3D model. So basically what I'm doing is navigating to where I saved my work, right? So if I click on it, you see that is the model that I want to attach. Okay, so select it. Now fortunately for me, it's seated exactly on the thing, as if just I have to do some small adjustments here. But there are times where you would have to use these things to rotate, to adjust to before it fits, right? But in this case, I think it did a good job by setting almost exactly on the thing. So we just have to move it a little bit forward. Okay, we can see that there is some space here. So to move it forward, which direction would be that? I think that would be the red one. Which one? So let's try it. Nope, not this. Oh, and we are not rotating, we are offsetting. Good. So but then this also offsets it too much. You can see that the pins are, so instead of using the linear increment, we can rather put in a value. So let's say 0.2, and I think right now it is setting, it is a little bit not matching the whole, but I mean that is definitely what we need. So let us try one, maybe 1.5. all right, so I think this is good. Okay, so once we are done, we hit OK, and now if we go to our 3D view, you see that all the components have been what? Assigned footprint, right? So now that this is out of the way, the next thing is to arrange the components how we want it to be. Is that okay? So usually I still want to maintain my flow. So now you can see that there are some lines here. Look at it. If I move this component about, you see that there are some lines. Okay, now these lines are we call them rat's nest. Okay, they are basically showing you where if anything connects, right? So this means that this particular signal connects, so you can see that this 12 volt connects to this 12 volt and it comes back somewhere there. So the first thing I want to put, so the first thing we have to do is to arrange the components as we want them. Is that okay? Now from this, I would like to arrange it in this way. I'll put my power in here and then put my switch. Since the switch has to be closer to the source, to the input, the power input, I'll put my switch to somewhere here. Is that okay? Now the rest would be where to mount the resistor. Well, so I can actually put this guy here, but that will become too tall, because now when we are arranging to, we have to also factor in the heights and all those stuff, right? So let's see, if we do this, we are wasting too much space and I don't like it. Okay, I wish there is a very simple way. Okay, how about we put this here, and now but if we put this here, okay, so you can put this here, put that here. Okay, I'm just trying to optimize the spacing so that we don't end up with something too huge. Oh, but this one too is not really nice. Okay, all right. Okay, how about, so usually unless you have a predefined arrangement, you would have to play around these things till you get what you want. But ideally, I think arranging it this way, or should rather try this. So my output would be somewhere like this. and then this guy can sit somewhere like that. Okay, so if I do this, then how about I rather bring this guy here, since it has to connect directly to this. Now, first of all, let me go and check the 3D view to see where the face of this screw terminal is. All right, so I've actually aligned it properly. So you see, that's the importance of the 3D model. It lets you see how the arrangement is going. Okay, so I think I'm gonna adopt this. I'd rather bring this here and bring that here, the middle. Good. And keep this guy here, put some spacing, and I will put my switch here. Okay, I think this is a good arrangement. This is a very good arrangement, right? So now if we check the 3D view, you see, yeah, it's not bad. It's not bad. It's not bad at all. Okay, so you connect the power here, you tap it from here, and your switch is there. I think it is good. Okay, besides, this is just to help you understand what PCB design is. Okay, now the next thing that we need to do is to draw an outline for the board. If you look at the 3D view, you realize that we have excess board running around, right? We don't want that. So we want to design the shape of the board. Okay, now tomorrow and the subsequent days we will talk more about this, but for now I just want to show you how to do this. So first of all, you come up here and select the edge cuts. Is that okay? So the dimensions or the boundary, the board boundary is, we call it edge cut in KiCAD. Okay, so you can select it here, or you can come to this manager, layer manager here, and select the edge. So make sure this edge cut is selected before you do what I'm about to tell you. Okay, once you select the edge cut, the next thing you need is to pick this line tool. You want to draw a line around. Is that okay? So it's the line tool that we want. So select the line tool, and now you draw the boundary of the thing of your board. Is that okay? So if this is what I want to do, I'll click here, and then maybe I would wanna do this scale thing here, move it down here. Okay, and probably give a little bit of pattern here for something I would do, put some style in it. Not necessary, but just put some style in it, bounce back, and then connect this straight up to this point. Okay, now one thing is that when you draw your boundary, it has to close. Okay, always make sure the line closes. Now if we zoom in, I think everything is intact. So if we go to the the 3D view, now we should see that the outline nicely matches what we have done. Is that okay? So even if you want to make circular dimension, whatever shape, in fact, there are times where you can import the shape from a CAD tool in the form of a DXF and use it as your outline. Okay, so this is just by the way. Okay, all right, now after doing this, the next thing we want to do is to set the layers. Okay, this work we basically just want to do it, we can do it on a one layer. Is that okay? But then I mean, 2-layer boards are cheaper right now, so I'm going to do it on a 2-layer board. Is that okay? And when you are at this point, you also have to consider something. Are you going to etch this board locally, or you are going to etch it professionally? Because if you are going to etch it professionally, then you have the flexibility of doing certain things, right? If you are going to do it locally, then you can't do certain things. Okay, great. Now the next thing I want, so if let's assume this board we are going to etch it locally, right? We are not going to send it to China. We are going to etch it locally. So if we are going to etch it locally, then ideally it will be easy to create it as a single-sided board. Okay, and because actually we are not even doing any long stuff here, so we'll just do it as a single-sided board. So the first thing I like to do is to go to edit the board setup. So you click on this particular button here, it will open what we call the board setup. So click on the second button here, the green one. It open board setup. It is trying to open. Okay, so if you come here, you have the board stack up, right? Tomorrow I'll explain more about this board stack up. So over here, it is about how many layers do you want to work with, okay? But then, if we come here, physical stack up, we can only choose up to two. Is that okay? We can actually choose up to two. But although the two is the minimum, we can actually choose two and still design on just one side of the copper. So yes, we will choose two. And basically for now we'll just leave everything here like that, okay? But another thing that is interesting is design rules, right? Since we are going to locally fabricate it, there is a minimum width that we can print out nicely without having breakages, right? So what I'm going to do is this. I'm going to set some rules that should govern our routing, our work. The first one is clearance. Clearance is the space between two copper traces. I'll show you what a copper trace is very soon. So it's like space. Take it as you have two wires passing by each other and you want to put space between the two wires. That space is what we call clearance. Now, for when we are developing the boards locally, you want to set this clearance large as possible. So usually I use 1 mm because I have realized that when you make it 1 mm, the traces print out nicely. You don't worry about short circuit and other things, right? 1 mm. And then the trace width. So like I said, I'll be showing you what the trace is. When you are going to do professional printing, in fact, you can print as low as a 0.2 mm trace. But if you want to do that locally by yourself, you can't do that. So the minimum our advice is to use 1 mm. But over here, we are going to set this to a minimum of 1.5 so that the traces will be large enough for us to print out. Is that okay? Then we have something called a via. A via is a hole moving from the top to the bottom, connecting two planes, right? In our situation, because we are going to do everything locally, we want to set this hole as big as possible. In fact, we can set this via to the same thickness of this or even more. So we can say the via should be 1.8 so that it will run out nicely. And the whole of the via, what I've seen is that it is very easy to get a 1 mm drill. Is that okay? Because after doing the work, you have to drill it. So if we make any via, we want the whole size to be as low as 1 mm. The rest of the things here, ignore them. We don't need it. Is that okay? All right. So now, there is something else we can do. We can assign, you see here, this net class. We call this rules a net class. You see that here it says default, right? But we can actually specifically say that certain traces should have different net class arrangements. For instance, we can add one and say this is for power. Anything that we will call power should have a clearance of 1 mm, all right, but the trace width should be much thicker because you are going to run a lot of current. So let's say we can say that the trace width should be about 2.5 instead of 1.5. The via width, we can keep everything the same. Then when we come down here, we can associate those things. So in our circuit, there is something called slash bats, right? We have a battery. Previously these things used to populate automatically. Okay. Let me see. Bats. You don't have anything matching bats. What about 12 plus 12V? Okay, these are power flags. So plus BATT. Yes. So see, the moment it matches, it says that there is something matching. So yes, any signal that is on the positive battery terminal, I want it to have the power class, right? So that means if I'm trying to route it, it will have this dimension. Also, let me add one for the 12 volts. So anything on the 12 volt. Now basically everything here is just going to be running on power, right? So this thing is technically not needed, so I can do it for the default and say that my default thickness should be the 2.5, or even let's just set it to 2. Okay, now how do I know that this trace weight should be 2? Now ideally you can calculate it based on the current that would pass through, the amount of temperature changes that you want to have and all that. I'll show you these things tomorrow, but for now we don't need all those complications. So just set this to 2, and we can set the VR size to 2.5 for it to have a nice rounding. All right, and then hit OK. Okay, so after hitting OK, the next thing that I'm going to do is to place what we call a power plane. Okay, I'm going to place a power plane, aka a ground plane to be specific. Now I'll explain what a ground plane is very soon, but the way you do that here, we want to do it on the bottom layer. So the bottom layer is what has been defined as BCU. Okay, bottom copper. CU stands for copper. FCU stands for top copper. Remember, we are dealing with just 2 layers, so we have just the front top copper and the bottom copper. But like I said, we are not doing a 2-layer board, we are just doing a 1-layer board, so everything will be connected at the bottom, right? So once you select the bottom copper, then you click on this field zone. Okay, we want to fill the copper with, we want to fill the board with copper, and label that, assign that the ground signal. Okay, so if you click on this, you can now start drawing around the shape. Okay, so you can see that I'm finding it difficult to change, to set. I want actually to set this as close as possible. Now you can, if you look here, you can see that the grade is set to 0.5, 0.25, right? I need it to be finer than this. So I can click on this grade editor, go to grade properties, and then remember I said for the schematic side, always keep it at 1.27. For the PCB side, you can set it as low as possible. Okay, now I want to use a user defined of 0.001 for the X, and also 0.001 for the Y. Okay, so once I set this, now I can change the grade. I can change the grade by doing this here. Okay, now you can see, so I can come here and select user grade, which is what I set, and you see that now it has changed to what? Grade 001, 001. Is that okay? So now if I want to draw my field zone, see, I have a much finer movement. Is that okay? So when you realize that your movement is coarse, just change the grade to a very low value. So now I can click here. Remember, we are routing this on the bottom, and this ground pour that we are doing, we want to associate it to the ground signal. Okay, so you route, we'll draw this around the entire board like that, and just follow the shape of the board. And again, it always has to close nicely. All right, so once I do this, I fill the entire base of the board with ground connection, right? Now if I hit on B, it will refresh the board, so you can see that now the thing has been filled with blue, showing that that's the bottom copper. And you can see that the number of lines, which I said was called rat's nest, it has changed. Is that okay? The number of lines have changed. It has become, because now all the ground planes have automatically connected to the bottom of the board. Is that okay? That is a good thing. Now look at something here. If we want to route this signal, you can see that there is a crossing over. The 12, we will route the battery through here, but the 12 volts would have to cross over it. Now technically we can pass that here, and route it, but I don't like it. Okay, I don't like it. I don't like it. Now, looking at the nature of this connector, actually, this is not what we plan to use. But let's assume that for a moment, we can use any of these pins, right? So it means that I can rather connect my 12 volts here for easy routing. Now, to do that, I'll have to go back to the schematic editor, come back here, and then I can, if I want the easy way out, I can just move this, right click on it, and say mirror vertically, right? So once I mirror vertically, it's like I've flipped the pins. Then after doing that, once again, I go to tools, update PCB, and once I update, you see the crossing has now, I've moved the signal from this pin to this pin rather. So now everything should be easy to connect. Now I don't want to see this blue background, so I can hide it by clicking on this particular button on the left toolbar. If I click on it, sorry, the base one, then it will hide it. It hasn't deleted it, it is there, just that it is not showing. So now the next thing to do is to connect these things, right? We connect them using the route, we call it routing. We have to create traces which will represent the physical connections between this component. It's almost like we are connecting wires to them. Remember, this is a copper board, so once we do those tracing, it's just like connecting copper wires to them. Is that okay? So the next thing, what we have to do is to select this, and then we click on that. Okay, now there is a problem. Okay, there is a problem. Remember the clearance and those dimensions that we set? Yes, that is what is creating the problem right now. Because of the clearance rule that we set, it's not allowing us, because basically this side is violating the rules. So there are two things we can do. If we still want to maintain the size of the copper, we can go back to the board setup editor and then edit the clearance that we set. Once we route it, we can go back and change that clearance to the one, just like we are the KiCAD will complain in the end, but then so far as we are aware of what we are doing, that is okay. Okay, so we can come back to the net class and reduce this clearance to, let's say, 0.3 mm. Okay, don't worry, we will bring it back. So 0.3 mm. So once we do this, I think we should be able to route now. So if I pick the route tool, I see that now I can connect. Okay, so let me pick it from here instead and connect that. So after doing this, I can then go back. Now you see, this is a special case because the pins, the pitch between the pins is what is making us do this. Okay, this is not an ideal thing to do, but then we don't have any choice. So we can now come back here and set our clearance to 1 again. Okay, of course we are done routing the thing that was a problem. In fact, before we do that, let us also route this signal. So this line connecting to this shows you that there has to be a trace going from here to here. So once again, I will do that nicely, but I think I rather prefer to pass it here nicely over there. And let's go to our board setup editor. Why does this thing take time to launch? Okay, so you see how simple all these things. I know for this, if this is your first time, it may not be that simple as I'm describing it, but basically it's simple and nice. Okay, so we come back here and change this from 0.3 to 1. Okay, definitely KiCAD is going to complain, but we know we intentionally did that, so we don't care. So now we are left with just one more trace to route. Okay, so the good thing about proper optimizing your component arrangement is that you tend to get better routing. Okay, so you see, we just connect this point, and just like that we are done. Is that okay? Just like that we are done, just like that. So if I hit B and then we can fill, bring back our, so you can see that we have this black space around this thing. These are empty spaces, so the copper within this space will be taken away, and the rest of the background, every place that is filled with blue represent copper, every place that is filled with black represents that the copper there has been removed. Is that okay? So basically that is that. If we check the 3D view, you should now see down here that we have the traces what connected. And ladies and gentlemen, this is just a very simple PCB. Okay, now the reason I left this space over here is because remember we said we assume that the lamp that we want to use is polar, so we have to nicely put a label there to show the user that please, you should connect the positive terminal here. So we can now put a label, and this label we'll put on the Silkscreen. So you come here, we choose, tomorrow I'll explain more about these things, Silkscreen, and we'll put here something like positive, right, or plus 12 volts. Okay, so we can just do plus 12 volt. We can, I think this will be okay. Now we want to put this on the top, so you realize that it has mirrored, right? But we want to put this on the top, so we press on E, or you can right click and select properties, and we will say mirror. So we will remove the mirror from it, and I think I would rather like to use 1 mm and set the thickness will adjust itself. Yes, so nicely we put this on top here, and then we'll duplicate it pressing Ctrl plus D, and then label it as G and D for ground. So this is just to show the user that, hey, this is where you connect your lamp terminals, okay, so that you don't mistakenly connect the terminals. Okay, so basically we are done, and we can also go ahead and put names on the various components. So here we can say, we can put a label here and call it switch. Okay, call it switch. So these labels go onto the Silkscreen. Unfortunately, because we are designing the board ourselves, we can't actually do this Silkscreen anyway, but I'm still going to put it there. Now this guy here, I want to replace it with a silk, with something I have typed, so I can actually hide this, right, by going to properties and then selecting visibility, turning off the visibility. See that it hides. You can actually do the same for every component. Now, usually when you design PCB, it's not advisable to leave the values of the PCB printed, right? That means if anybody gets your PCB, they can easily duplicate it. You don't want that. So it's a good thing to hide the values and just leave the references, okay? So to do that collectively, you can come to this side, the appearance or layer manager, select on the object, and you can say, you can turn off values. Okay, so if I turn off values, you see that everything that is associated with value is off, leaving only references. So even if I want to turn off references, I can still do that. Okay, but I want to keep the references. In fact, it's a good thing to keep the references, okay, because that is how you identify components and solder them. Then let us put a name on this. You label this and call it battery 12 volts. So 12V battery. Okay, so just 12 volt bat will do, so that you know that this thing requires just 12 volts, and I think we are good. So if I save this, press on B to update it, and then we go back to the 3D view, see that we have nicely created our board. Now this space here, let us use it for something interesting. So we are going to put some name there, something fancy over there. So because of that, I would move this label from this reference from here to somewhere here. That would do. and I'm going to put a text there. So let's say, don't forget that anytime we are doing this text things, is you have to be on the F Silkscreen, right? Front Silkscreen. If you want to do it on the bottom, to then the B Silkscreen. All right, so yeah, let's say, how should we even call it? Let's call it garage lamp. Okay, in fact, you can put images and a lot of things. I'll show you how to do images, God willing, tomorrow. So no matter what you are doing, please don't miss tomorrow. And I want it to center, I want it to knock out. You will see how the knockout behaves. So you see the knockout rather kind of subtract the text from the background, right? But then we want this, we don't want it inverted, because we are putting it on the top layer. So we make sure we click on this mirror thing and get it rightly oriented. Okay, so ladies and gentlemen, that is our garage circuit. Okay, nicely done. This is time to clap for yourself. So what is left is that now, if you want to etch it locally, I will show you the process, but not today. Our time is fast spent. Okay, so basically this is the circuit that we need to power our garage lamp, as we described in the theory sessions today. Okay, all right, so any questions up to this point? Any questions up to this point? So the reason I did this was so that you can spend time overnight and try to replicate it, right? So if you have any questions, I'm glad